there, everybody. This video lesson is going to go over the equations and graphs of parabolas. We will identify and use the focus, the directrix, and the vertex to do this. So I know we've had some experience with parabolas. We used parabolas in Algebra 1 when we saw that they were the graph of a quadratic function or a quadratic equation. In Algebra 1, they only opened up and down. We're going to see in this video they can open up, down, to the right, or to the left, because we are looking at parabolas from a different point of view. We're looking at the geometric definition of parabolas. So the geometric definition states that a parabola is just one type of conic section. If you know the other conic sections, there are circles, parabolas, hyperbolas, and ellipses. Usually the parabola is the first one you learn because you're sort of familiar with it from Algebra 1. And so what happens is when we have a double-napped cone, a right cone, so not oblique, not slanted to the side, and you have one on top of another, and you have a two-dimensional plane that intersects that cone, it will intersect at this angle and give us a parabola. We get different angles depending on if we came down perpendicular, if we came down horizontal. We're just looking at the parabola. So this 2D plane, think of a piece of paper cutting this cone at this angle, making that familiar shape, that U shape that we're familiar with. All right, so the first thing you might see in your textbook is a definition that looks a little daunting. The definition of a parabola, the technical mathy definition, is that it's the set of all points that are equidistant to some point called the focus and a line called the directrix. Well, both the focus and directrix are new terms, and this definition is a little wordy, so let's just look at it with a visual. So here we have the parabola we're used to, right? This little U-shaped graph. The focus is a point, it's a very specific point within the curve. It always falls within the curve of the parabola. So what this definition is saying is that you have a parabola if every single point along the curve of the parabola is equidistant to this point, the focus within the curve, and this line, the directrix. It's important to note, from the point, you have to drop a perpendicular line to get to the directrix for these to be equal. You can't say that I'm going to go from this point all the way over here, hit the directrix, and say, oh, those must be equal. They're not going to be equidistant unless you drop a perpendicular line from that point. So we are going to use a very specific point. We're not going to use this arbitrary point xy. Here we just labeled some point xy. This relationship exists for all points, but we're going to use the vertex because it's a super specific point. It's something we're already familiar with, and it'll make graphing these a lot easier. So just remember, every single point on the parabola is the same distance from the focus as it is the directrix, as long as we drop a perpendicular line from that point. All right, let's look at a parabola. Let's label everything we need and see how we're going to use these. So this is the graph of a parabola. It looks actually pretty familiar. This could be the graph of a parabola we saw in Algebra 1. It opens upward, right? So we have an axis or a line of symmetry. Remember the line of symmetry, because parabolas are symmetrical. The line of symmetry goes right through the vertex. It goes through the x-coordinate of this vertex because it is an up and down parabola. In addition to that, we have the new point we just learned about, the focus. If you think about the focus, try to remember it's within the curve. Think of a satellite dish. A satellite dish is in the shape of a parabola. It's parabolic, as we call it. And the focus is that central point that all of the transmissions point to before going out. So if you wanted a real life, how do I picture this? Picture a satellite dish. So we have the focus. Remember, we have the vertex. We'll talk more about that. In Algebra 1, the vertex was the absolute minimum or the absolute maximum. You'll see that's not always the case in geometry because not all of the parabolas we're going to look at are functions. But in this case, this opens up. The vertex is the absolute minimum of that graph. And then we have the directrix. The directrix, remember, is going to be, in this case, it's going to be a horizontal line. So it's going to be an x equals line. This is actually x equals negative 1.5. And so this is going to be equidistant to the vertex as the focus is. So the vertex is the same distance from the focus as it is the directrix. Whew, easy for me to say. So that's the relationship we're really going to be looking at. The next new thing we're going to look at is the standard form for the equation of a parabola in geometry. This is the geometric, it's really the standard equation. I call it the geometric equation. It's not ax squared plus bx plus c that you remember from Algebra 1. This looks very different, so let's go through it. It is x minus h squared. So notice the x term is the variable that's squared. The x is the variable that's squared. That's what tells us it opens up or down. So that's why this one looks familiar. We're going to have another equation where x isn't squared. So x minus h squared equals 4p. The entire expression 4p is new here, so we'll go through that. Times the quantity y minus k. All this is only true as long as p is not 0. So as long as we're talking about p, what is p? P is simply a distance. That distance we were talking about from the vertex to the focus and from the vertex to the directrix, that distance is p. P is the distance from the vertex to either the directrix or the focus. If p is positive and x is squared, this thing opens up. If p is negative and x is the variable squared, this thing opens down. So let's look on the graph and see where p is. So this little distance here is p, this little distance here is p. So it actually comes in super handy, even though we've never seen it before. And a lot of times your first instinct is to say there's never been a p in the graph or in the equation of a quadratic. Where did this come from? Remember, we're looking at parabolas geometrically. All right, so let's label everything. Let's figure out how to find everything. The vertex we should remember is HK. That's what it was in Algebra 1 when we had to find the vertex. It was HK. And remember, we take the opposite sign of h and k. X minus h, think of this as negative h. We have negated the sign of h, so you're going to take the opposite sign of h, opposite sign of k. Remember, h is always paired with x, k is always paired with y. So now if we think about this, the focus, because this opens up and down, the focus is p distance away from the vertex. So how are we going to find it? The h coordinate is going to stay, or the x coordinate is going to stay the same because it's getting higher. It's higher than the vertex. We are going to say keep the x coordinate, or h, the same, and take the y coordinate and add the value of p. And that's how you're going to get your focus. If you're plotting these, you might just want to plot the vertex, see what p is, and count up and plot it. For the directrix, you're going to do the exact same thing, except you're going to subtract it, because remember, the focus is within the parabola and the directrix is outside of it. It's outside of the vertex. So we are going to take the vertex and we are going to subtract the amount of p. Remember, it's a y equals equation. This is y equals negative 1.5. We are going to subtract however much p is to get this. So we have negative, what do we have? 4, negative 1 is our vertex. Subtract 1/2. We have 4, negative 1.5. We've subtracted 1/2. We've written it as an equation because it's a horizontal line, and that's our directrix. So I know we've never dealt with directrix before. Remember, that's a horizontal or a vertical line, as we'll see coming up, and the focus is an actual point. So the vertex is a point, the focus is a point, the directrix is a line. All right, moving on, let's see a different type of parabola. So here we have a parabola. It would not pass the function test, right? For each input, you're going to have 2 outputs here. This fails. It's not a function. That's why we never saw it in Algebra 1. So let's label everything we already know. It still has a line of symmetry or an axis of symmetry, whatever you call it. It still goes right through the vertex. This time it goes through the y coordinate because it's horizontal. We have a focus. It's still within the bell of the parabola, just like it was when it opened up. We have the directrix, right? Notice the directrix, again, is behind. It's always beneath this vertex. It's never within. This time it's a vertical line because we open sideways. So this is going to be an x equals equation. And once again, we have the vertex, which we've been familiar with. So the standard form for this parabola, when it opens to the left or to the right, slightly different. Instead of squaring x, we are squaring y. Notice it's y minus k squared. K is still with y, equals 4p times the quantity x minus h. P still can't be 0, and p hasn't changed. P is still the distance from the vertex to either the directrix or the focus. This time, though, if p is positive, then it opens to the right. If p is negative, the parabola opens to the left. And let's look at p on the graph. So here we have the distance of p, and here we have the distance of p shown. And remember, these are the same. You can't use the same variable to represent numbers that aren't the same. So vertex, still the same distance from the directrix as it is the vertex. We're just flipping it a little. It's open on its side now. The vertex is still going to be located at HK. Remember, H is with X, K is with Y. We're still going to take the opposite signs of H and K. It's still a negative H, or we're negating H, right? If H were negative, let's say H were negative 2, X minus a negative 2 would be X plus 2. So we're always taking that opposite sign. Okay, the focus, this time, the Y coordinate is going to stay the same, right? Here's the point, negative 2, 1. Well, for the focus, Y is still going to be 1. We're just moving to the right. So you're going to take the X coordinate and add P to it. You're going to add that distance to get to the right. With the directrix, we're going to start at the vertex, and we are going to subtract P from the X coordinate. So it's X equals H minus P. Why is it X equals? Because vertical lines are X equals. Remember, vertical line is an X equals because all the X coordinates on this line are the same. All right, let's move on to something else. Given this equation, let's now identify everything we've just talked about. So we have the equation x plus 1 squared equals negative 12 times the quantity y minus 6. And we want to identify the vertex, focus, directrix, axis of symmetry. I'm even going to sketch it, or I'm going to give everything I can to sketch it. So what do we know right away? We should know if it opens up or down, and then if it opens right or left. And we should know the vertex. So let's see how. The variable that's squared is x. So right away I know this either opens up or down. And I notice that the new term, the 4p, is negative 12. If 4p is negative 12, then p has to be negative. So it opens down, right? The x being squared tells us up or down. The 4p, this term right here being negative, says down. All right. So we still have hk, right? So this is x minus h. We still have, and y minus k. So we still have hk, vertex hk, take the opposite sign. So h is negative 1, k is positive 6, giving us a vertex at negative 1, 6. Now the directions didn't say to plot it, but it's super easy to visualize these if you do plot it. So I'm just going to make a quick little plot here of everything we see. So now that I know the vertex is negative 1, 6, I know this thing opens down. I know my axis of symmetry has to go right through that vertex, so it has to be x equals negative 1. So let's put it on there. Now let's deal with this 4p expression. We're going to put together a little simple equation. We're going to say 4p equals negative 12. If we solve for p, we just divide by 4, and we get that p is negative 3. That gives us the distance between this vertex and the focus that'll be here and the directrix that'll be back here. So we now know the focus is 3 below the vertex and the directrix is 3 above or behind, however you want to visualize that. So let's put that in. The focus, we're going to go from the vertex 1, 2, 3. We're going to see that the focus will be at negative 1, 3. So we'll put that there. We'll plot it on the graph. From the vertex, we'll count back 1, 2, 3. We're here at y equals 9. So that's exactly what the directrix will be, y equals 9, and we'll plot it. And then from here, we could graph it, but I'm going to use Desmos, desmos.com, great graphing tool if you don't already know about it. And that is the graph of that equation. All right, let's look at one that doesn't open up or down. Given the equation y minus 4 squared equals 20 x plus 2, or 20 times the quantity x plus 2, we want to identify the same exact things. So again, what do we know right away? We should know which way it opens and the vertex. Those are the two easiest things to find. So the variable that is squared is y, right? We have y minus 4 squared. So this is going to either open to the right or to the left. We are going to look at this term and see that 4p is 20. Since 4p is 20, p is positive. This parabola opens to the right. Vertex is still hk, but be careful. Remember, h is with x, k is with y. Just because the y comes first, the y expression comes first, don't go grabbing this positive 4 for your h. So vertex hk, h is negative 2, the opposite of positive 2, and k is positive 4, the opposite of negative 4. All right, I'm going to plot it again because, again, it's super easy if I just sketch this. Remember, the 4p term is 20. I'm going to use that to figure out the distance to the focus and the directrix. So 4p equals 20. I'm going to divide by 4 again. P is 5. So this thing opens to the right. That means the focus is 5 to the right from the vertex and the directrix is 5 to the left. So we're going to go ahead and count 1, 2, 3, 4, 5. We're going to plot our focus right there. It is at, and we're going to go back, 1, 2, 3, 4, 5, and we're going to put our directrix right there at x equals -7. Now let's fill in the data. So 3, 4 is where we plotted the focus. The directrix was x equals -7. We could have done the axis of symmetry immediately. We just didn't. It's going to go right through the vertex. So that's the horizontal line, y equals 4. And that's it. That's everything I need to graph that guy. All right. Let's talk about writing equations of parabolas. When we write the equation, we're sometimes given the parabola itself. Sometimes we're given other information. We'll look at that. So to write the equation of this parabola, let's figure out what we've been given. It looks like we've been given the directrix. We can tell the vertex, and we have the focus. So we have a lot of information here. I have the vertex, and I have either the focus or the directrix. Then I also have P. That's really all I need. I just need vertex and P. So since this opens to the right, let's figure out what equation we're using first, and then let's plug in the information we just talked about. It opens to the right, so we're going to use y minus k squared equals 4p times x minus h. And again, I know the vertex is right here, -2, 1. So I know h and k. H is -2, k is 1. I also know the focus, right? Here's the vertex so that you could see it more clearly. Here's the focus that was already given to us. The focus happens at -1, 1, so it's just 1 away from the vertex. So P is 1. All right, so that's everything I need. Believe it or not, if I have the vertex and I have P, I have everything I need. Let's plug it all into the equation. Okay, so we have y minus 1. Remember, y was 1 here. This is y minus k, so k is the y coordinate of the vertex, equals 4 times, what's the distance? P is 1, so 4 times 1, x minus -2. Remember, we have a -2. We always take the opposite, so it's x minus -2. Let's clean that up and not leave it like that. Our equation is y minus 1 squared equals 4 times the quantity x plus 2. All right, what if they don't give you a graph? What if they give you some information like this? They say write the equation of a parabola with a focus at 2, -1 and a vertex at -4, -1. That's exactly what they just gave us, except before it was visual. And you might prefer that. So we don't need to sketch the points, right? We don't need to plot this, but it is really helpful, especially if you visualize it better, especially if you found that last problem easier than this problem. So let's go ahead and plot -4, -1 as our vertex and 2, -1 as our focus. So what can we see from this? Well, I know this is our vertex and this is our focus, so I know that the focus is always within the bell of the parabola, so I know it opens to the right. I also can tell the distance P, 1, 2, 3, 4, 5, 6. So the distance P is going to be 6. So P equals 6, because I just counted, it's the distance. I know the parabola opens to the right. I know that P must be +6, because if it wasn't positive, it wouldn't open to the right. They gave me the vertex. Again, I have vertex, I have P, I know the sign of P because I know which way it opens. I can just plug this stuff in. So let's plug it in. Y minus, what's K? -1, so y minus -1 squared equals 4 times what's P? P is 6, times the quantity x minus, what is H? -4. Again, clean that up, don't leave it like that. Y plus 1 squared equals 24 times the quantity x plus 4. Done. All right, we are going to do one more sketch because the question that came in says, I'm having trouble with parabolas, graphing them, equations, and I have to use 3 points. So I'm going to assume I know what his teacher's talking about when she says 3 points, because sometimes it is nice to have 3 points. But if you're going to get 3 points, I'm going to tell you the way these work, you're going to get 4. Let's see why. All right, so we'll put the graph up there. What do we know right away? Well, we know that the y is the variable that's squared, so it either opens to the right or to the left. And we know that 16 is positive, so P is positive, so it opens to the right. All right, and remember, we already know that P is going to be 4 because 4P equals 16, divide by 4, P is 4. But let's take it one step at a time. The vertex is HK. Remember to grab, oh, my mouse went crazy. Remember to grab H from the X, K from the Y. So we see that the vertex is -2, -1. We can plot that and make it easy. Now, 4p equals 16 gives us p as 4. So the distance between the vertex and the focus, as well as the vertex and the directrix, is 4. We already set it open to the right, so I know 1, 2, 3, 4. 2, -1 is where my focus should be. Or we could use that formula that we were given in the beginning. But again, the graph you could just count and plot. So 2, -1 is my focus. Now I'm going to count backwards 4. 1, 2, 3, 4. X equals -6 is our directrix. And we have everything we need, except the question specifically said use 3 points. So we're going to plug in a point. Like right now, we don't have 2 points. We have 1 point. So if we want 3 points, we're going to have to plug in some value for x. Let's plug in 2. So if we plug in 2 for x here, I'm going to do it really quickly and just show all the work. We're going to get y plus 1 squared equals 16 times 2 plus 2. So 2 plus 2 is 4 times 16 is 64. That gives us y plus 1 squared equals 64. Take the square root of both sides. We get y plus 1 equals positive and -8. Subtract 1 from positive 8, we get 7. Subtract 1 from -8, we get -9. Take a piece of paper if that was way too much and kind of work it out and see where I was coming from. So we get 2, 7. Remember, this isn't a function. We're going to have 2 outputs for 2. So 2, 7 and 2, -9, which is off the graph. And my sketch is not going to really hit it anyway. So I put 2, 7 up there. I didn't put 2, -9, and that's as good as it gets. So your teacher really just wants to know, is it wide or is it skinny? And so when you go ahead and solve for the 3 points, you have the 1 as the vertex. You solve for 2 more just by plugging any point in. That'll get you a more accurate graph. That was a really long video. If you still have questions, if that didn't answer your question, hit me up on YouTube. You could always send me an email. My email's on my YouTube, or you could just comment on the video. Thanks so much, and have a good one.